The following program is rated G. It is suitable for all audiences.
Today, I'm going to discuss about the vertex and standard form of quadratic equation, wherein you'll learn how to convert equations in vertex form to standard form and vice versa. Before I hand down to you the methods, formulas, and examples, let's first define the term quadratic function. Quadratic function is a function that can be described by an equation of the form f of x is equals to ax squared plus bx plus c, where a is not equals to 0. Now let's have these points to ponder. Always remember, the greatest power of the variable in a quadratic function is 2. Not negative 1, not 0, not 1 or 3, but 2. Also take note that the graph of a quadratic function is called the parabola. This is how a parabola looks like. Anyway, going back to the topic, there are two forms of quadratic equation. First is the standard form, described by the equation presented earlier, which is f of x is equals to ax squared plus bx plus c, where a is not equals to 0. And second is the vertex form, described by the equation f of x is equals to a times the quantity of x minus h squared plus k, where a is not equals to 0. We have formulas that we will use to be able to convert equations in vertex form to standard form and vice versa. Let's first look closely on the standard to vertex form. Since we're going to convert the equation into its vertex form, we need to have the values of a, h, and k. For the standard to vertex, these are the formulas. A is equals to a, h is equals to negative b over 2a, and k is equals to c minus ah squared, or you may also use c minus b squared over 4a. Now let's check on the vertex to standard form. Since we're going to convert the equation into its standard form, we need to have the values of a, b, and c. With that, here are the formulas. A is equals to a, b is equals to negative 2ah, and c is equals to ah squared plus k. Now that we're all set, let's move on to the first example, where we will convert equations from standard form to vertex form. Suppose that the given equation is f of x is equals to 2x squared plus 12x plus 10, which is obviously in its standard form. This already gives us a hint that the given should be changed into its vertex form. The first thing you have to do is to identify which of these numbers present in the equation is the value of a, b, and c. In this case, a is equals to 2, b is equals to 12, and c is equals to 10. These values will be used in identifying this time the values of a, h, and k, which is necessary in vertex form. Let's solve it. A is equals to a, so a is equals to 2. H is equals to negative b over 2a. Your b is 12 and your a is 2. If we're going to equate that, it will be negative 12 over 2 times 2. Simplifying it, it will be negative 12 over 4, which is equals to negative 3. Now for k, we will use the formula c minus ah squared. C is 10, a is 2, and h is negative 3. If we're going to equate that, it will be 10 minus 2 times negative 3 squared. Simplifying it, it will be 10 minus 2 times 9, and again 10 minus 18, which is equals to negative 8. Now that we have the values of a, h, and k, we can now arrange the values in the vertex form. F of x is equals to a times the quantity of x minus h squared plus k. With that, our answer is f of x is equals to 2 times the quantity of x plus 3 squared minus 8. Take note! If h is negative, then it becomes positive when you place it inside the parenthesis. And if h is positive, it becomes negative once you place it inside the parentheses. We'll now go on with the second example, where we will convert equations from vertex form to standard form. The example that we're going to use is more like a checking strategy to verify if our previous answer is correct. Yet, the procedure here is the same in converting standard form to vertex form, so we'll use this example. Suppose that the given equation is f of x is equals to 2 times the quantity of x plus 3 squared minus 8, that is, in its vertex form, should be converted into its standard form. Same as the first step in the first example, you need to identify values. But this time, the values of a, h, and k. Here, the values of a is 2, the value of h is negative 3, and the value of k is negative 8. Having the values of a, h, and k, let's now push through solving for the values of a, b, and c by using the formulas presented before. Again, a is equals to a, so a is equals to 2. b is equals to negative 2ah. Your a is 2, and your h is negative 3. If we're going to equate that, it will be negative 2 times negative 3, which is simplified for negative 2 times negative 6, which is equals to 12. And for c, it is ah squared plus k. Your a is 2, your h is negative 3, and your k is negative 8. If we're going to equate that, we'll have 2 times negative 3 squared plus negative 8. If we're going to simplify it, it will be 2 times 9 minus 8, which is equals to 18 minus 8, wherein we'll get the value of c, which is 10. Same as the first example, now that we have the values, we can now arrange the values in the standard form f of x is equals to ax squared plus bx plus c. Our final answer is f of x is equals to 2x squared plus 12x plus 10. Take note, since we used this example, just like a checking strategy on our previous answer, our final answer must be equal to the original equation. There you go. That is all for the vertex and standard form of quadratic equation and conversion of equations in vertex form to standard form and vice versa. I hope you learned something from this discussion. Until next time, bye!